Good day, everyone. In this lesson, we are going to learn on how to solve problems involving logistic growth. In our previous lesson, we've discussed about how to solve problems involving bounded growth, and logistic growth is an example of a bounded growth problem. Now, to solve logistic growth problems, we are going to use the logistic growth equation y is equal to k all over 1 plus c times a raised to the power of k times t. For our example, 10 Philippine eagles were introduced to a national park 10 years ago. There are now 23 eagles in the park. The park can support a maximum of 100 eagles. Assuming a logistic growth model, when will the eagle population reach 50? This problem is also an example of a bounded growth because there is a carrying capacity stated in the problem. But since the logistic growth model is stated in the problem, hence we are going to use the logistic growth equation to solve the problem and not the bounded growth equation. If the logistic growth model is not stated in the problem, then we are going to use the general solution for the bounded growth equation. Now, to solve this problem, our first step, okay, our first step is to define, the variables. Okay, so that is our first step. Okay, so here from our problem, we are going to define our variable y and t. Okay, so we need to let y, be the number, or the number, okay, the number of, okay, the number of eagles, okay, the number of eagles at any given time, at any given, at any given time, okay, and t, and t is the, okay, is the number of years, is the number of years, okay, is the number of years after, after the eagles, after the eagles, were first, okay, were first, okay, were first introduced to the park, okay, to the park. So here are our variables. We have y, the number of eagles at any given time, and t will be the number of years after the eagles were first introduced to the park. Okay, since we have now the variables, so our next step, so this will be our step 1, so our next step, which is our step 2, step 2 is to identify the initial condition. We need to identify, identify the initial conditions. So that's our second step, initial conditions. Okay, now based on the problem, since we have 10 Philippine eagles that were introduced to a national park 10 years ago, so that means the original number of Philippine eagle in the park is 10. So that is at t is equal to 0, the number, the number of Philippine eagle is 10. So that is y is equal to 10. So that means this is our first initial condition. Also, since now there are 23 Philippine eagles in the park, so that means at t is equal to 10, the number of Philippine eagle in the park, is equal to 23. So this is now our second initial conditions. And also, we have the carrying capacity, which is stated in the problem. The maximum number of gigas that the part can support. Okay, so that is equal to 100 gigas. Okay, so we have now our first initial condition, our second initial condition, and we also have the carrying capacity. Okay, for our third step, we need to solve, okay? We need to solve for C, okay? We need to solve for the variable C. And to solve for the variable C, all you need to do is to plug in the first initial condition and the value of K to the general solution of the logistic growth equation, okay? And that is, okay, we know that the logistic growth equation is equal to Y is equal to K, or the carrying capacity, all over 1 plus C times, okay, times A raised to K times T. So that is the formula. Okay, that is the formula for the logistic growth. Then plug in, okay, plug in the first initial condition to this formula and the value of K. So that is the value of Y, we have 10, okay, and we also have the value of K, which is equal to 100, okay, then all over 1 plus C times, okay, times A raised to 100 times 0, okay. Then let's simplify this one. So we have here 10, okay, we have here 10 is equal to 100, okay, all over 1 plus, okay, 1 plus C, okay, since A raised to 0 is just equal to 1, so that gives us C, okay. And then let's continue this one right here. Okay, so we have 10, let's copy that one first. We have 10, then 100 over 1 plus C, and we need to cross multiply, so we have 10, okay, we have 10 plus 10C is equal to 100, okay. So since our goal is to solve for C, adding both sides by negative 10, we have 10C is equal to 90. Then we divide both sides by 10, so that will give us the value of C, which is equal to 9. Okay, now for our fourth step, okay, now for our fourth step, okay, we solve for the value of A. And to solve for A, all you need to do is plug in the value of the second initial conditions, the value of K, and the C. Okay, so we know that the second initial condition, we have T is equal to 10, the value of Y is equal to 23, and K, also have the value of K, which is equal to 100, and the value of C that we solved earlier is equal to 9. Okay, so plug in this value into the general solution of the logistic growth equation. We have, okay, so we have Y is equal to K over, okay, over 1 plus C times A raised to K times T. Okay, so we just simply plug in the value. So we have Y, which is equal to 23, our K 100, 1, then plus the value of C, which is equal to 9, okay, then times A, okay, then raised to 100 times, okay, times the value of T, which is equal to 10. Okay, so That's it. And then let's simplify this one. So we have here 23 is equal to 100 over 1 plus 9 times a raised to a raised to 1000. Okay, so a raised to 1000. So let's continue this one right here. So since we don't have a space now, so let's continue this one right here. So we have, let's copy that one first. So we have 23 is equal to 100 over, okay, over 1 plus 9 times a raised to 1000. Okay, and then let's cross multiply this one. So we have 23 plus, okay, plus, okay, 23 times 9, so we have 23 times 9, okay, times a raised to 1000, okay, that equal to 100. Okay, so here let's simplify this. So we have 23 plus 23 times 9, that is equal to, okay, that is equal to 207. So we have 207, okay, times a raised to 1000, okay, equal to 100. Okay, then next thing that we need to do is we isolate the a variable. So first let's add both sides by negative 23. So we left here on the left side 207 a raised to 1000. Okay, then on the right side we have 23 at 100 minus 23, so that is equal to 77. Okay, so that is equal to 77. Okay, and then, okay, to solve for, let's isolate the a variable. So let's divide both sides by 207. Okay, 207. So here we're left with a raised to 1000 is equal to 77 over 207. Okay, so let's continue this one. Okay, let's continue this one right here. So let's copy this one right here. So we have a raised to 1000 is equal to 77. Okay, 77 over, okay, 207. Okay, so now since our goal is to solve for a, so we need to get rid of the exponent right here. So what we are going to do is to get the 1000 root, okay, of both sides. Okay, so that's the way, no, to get rid of the exponent. So here on the left side, this one cancels out, so we now left with a, the variable a, and on the right side, this one is just equivalent to 77 over 207, okay, raised to 1 over 1000. Okay, so here's now the value of a. Our next step, okay, our next step is to write, okay, we need to write the particular solution, okay, the particular solution, okay, of the logistic growth equation. Okay, and we know that based on our computation earlier, we have the value of c, which is equal to 9. We also have the value of a, which is equal to 77 over 207 raised to 1 over 1000, and then the value of k, which is equal to 100. So we need to plug in these values into the general solution of the logistic growth equation to find the particular solution. So we have y is equal to k over 1 plus c times a raised to k times t. Okay, so let's plug in the value. So we have y is equal to the value of k, the carrying capacity 100 over 1 plus c, which is equal to 9, and then the value of a. Okay, the value of a, which is equal to 77. Okay, we have 77 over 207, okay, raised to 1 over 1000, and then raised to the value of k, 100, okay, times t, okay, times the t. Okay, so let's simplify this one. So we have y is equal to 100, okay, over 1 plus, okay, 1 plus 9, okay, 9 times, okay, 77, okay, 77 over 207 raised to, of course, we need to multiply the exponent, so we have, okay, 1 over 1000 times 100, so that gives us 1 over 10t. Okay, so this is 1 over 10t. So this is now the particular, okay, the particular solution. Okay, the particular solution of the logistic growth equation. Okay, so this will help us determine, okay, determine the number, okay, the number of Philippine eagle in the park at any given time. Then for the final step, okay, for the final step, we need to answer the question when, okay, when when will the, okay, the eagle, okay, the eagle population, okay, population reach 50. Okay, so in other words, we are solving for the time. Okay, again, we are not solving for the number, okay, for the number of eagle, but we are solving for t, okay, or the time. Okay, and to solve for, okay, and to solve for the time, so what we are going to do is, of course, to use, okay, we use the particular solution of the logistic growth equation and solve for t. Okay, so we have the particular solution, y is equal to 100 all over 1 plus 9 times 77 over 207 raised to, okay, t over 10, or 110t. They're just the same. Okay, now since we have the given population, no, we have the given population 50, so we need to use this one as the value of y, then we solve for t. Okay, so we have y is equal to 50, so we have 50 is equal to 100, okay, then all over 1 plus, okay, 9, okay, 9 times, okay, 77 over 207 raised to t over 10. Okay, then we cross multiply, so we have 50. Okay, so we have 50 plus, okay, so 50 times 9, that is equal to, okay, 450. Okay, so that is equal to 450 times, okay, of course, times 77 over 207 raised to the 10, okay, then equal to 100. Okay, and then, of course, okay, so what we are going to do here is to isolate, okay, is to isolate this one, okay, this term right here. So we need to add first, okay, we need to add both sides by negative 50, so we're left with 450, okay, 450, okay, times 77 over 207 t over 10, and then here 50 100 minus 50, so that gives us 50. Okay, so let's continue this one right here. Okay, so here we have, let's copy this one first. So we have 450. Okay, 450 times 77 over 207, then raised to t over 10 is equal to 50. Okay, so again, let's divide both sides. Okay, let's divide both sides by 450. Okay, 450. So that will, so here we're left with, okay, 77. Okay, 77 over 207 raised to t over 10. Okay, then here 50 divided by 450, so that is equal to 1 over 9. Okay, so now since the variable is on the exponent, so what we are going to do is we need to apply, okay, we need to apply the natural logarithm on both sides. Okay, so here we have the natural logarithm, so we have ln, okay, ln, and then we have here 77 over 207, okay, raised to t over 10. And then on the left side, same thing with the left side, okay, to maintain equality. So we have ln, and then, okay, 1 over 9. Okay, so now according to the property of natural logarithms, of course, if you have here, if you have this one, this expression, so what you are going to do is you are going to bring the exponent on the front. So we have, okay, so you have, okay, so t over 10, okay, then times, okay, times ln, ln 77 over 207, okay, and then equal to the L and 1 over 9. So let's continue right here. Let's divide both sides by ln, okay, 77 over 207, okay, ln 77 over 207. So this one, okay, cancels out, so we left with, okay, we left with t over 10 is equal to, okay, ln, okay, ln 1 over 9 over ln 77 over 207. Okay, so to solve for t, so all you need to do is multiply both sides by 10. Okay, so if you multiply both sides by 10, so here we're left with t, and then here on the right side we have, okay, we have 10 times, okay, ln 1 over 9 over ln 77 over 207. Okay, and let's use our calculator to solve this one. Okay, let's use our calculator. So we have 10, okay, times, okay, so we have ln 1 over 9, okay, then over, okay, over the natural logarithm of 77 over 207. Okay, then click equal, so that will give you approximately equal to 22.22. Okay, so then for our conclusion, okay, the eagle population, okay, the eagle population will reach, okay, will reach 50, okay, will reach 50 in approximately, okay, in approximately, okay, in approximately 22 years. Okay, so that's the answer for this